Alright, so this video has two pieces in it. We're going to be talking about what is the biconditional and then what is the law of syllogism. Okay, so first off, the biconditional relates very closely to our if-then statements that we talked about in the last video. We talk about the true if-then statement, like the original if-then statement, and then its converse as well when we're discussing the biconditional. Okay, so that's our P implies Q, and then the reverse, which is the Q implies P. Okay, so that's our statement and its converse here. And what we're talking about here when it's a biconditional, it means that both ways are true. So P implies Q and Q implies P. All right, it means that this is going to be true and that's going to be true. So the way we say it in a biconditional is P if and only if implies Q. Okay, so let's take a look at it in an example here. So let's take a look at the Pythagorean theorem one we talked about yesterday. If you have a 90-degree right triangle, right? So I'm kind of shorthanding here, but hopefully you're listening to the audio as well. Then that implies that we can use the Pythagorean theorem, right? If we have a right triangle, we can use the Pythagorean theorem. We should all know that, right? That's our a squared plus b squared equals c squared. All right, now let's talk about the converse. Remember, the converse just switches the order. So if you can use the Pythagorean theorem, which is a squared plus b squared equals c squared, then you know you have a 90-degree right triangle, right? And both of those in that situation are true, right? This is true and this is true. So that's where we have a true biconditional. Both directions are true. If and only if goes in both directions, right? If you have a 90-degree right triangle, if and only if you can use the Pythagorean theorem, right? So it's talking about both directions here. Another example of another biconditional we see is, let's take a look at equilateral triangles and what those means. Okay, so let's say all three sides of your triangle are congruent. So all three sides are congruent. If and only if you have an equilateral triangle. Right? So let's think about both directions here. If all three sides are congruent, then you must have an equilateral triangle, right? And if you have an equilateral triangle, then all three sides must be congruent. And you know that's true in both directions here, right? And we're kind of just saying the definition here, right? We're using the definition of an equilateral triangle, right? The definition of an equilateral triangle is, all three sides are congruent. Well, if you have three sides that are congruent, it must be equilateral. Okay, so that's another example of a biconditional that we have, and it's true in both directions. Now let's take a look at an example where it's not true. Okay, so let's assume that we have a biconditional here where we're talking about linear pairs. Okay, so a linear pair is if and only if my angles are adjacent. And remember, we want to go in both directions here. We want to go in the statement's direction and we want to go in the converse direction. So if you have a linear pair, right, then the two angles must be adjacent. Okay, that's true, right? If I have angle 1 here and angle 2, they're next to each other, right? That means they're adjacent. So that direction is true. So if we want to just indicate it, you don't need to do this, but you can say in this direction, it's true. Okay, but let's think about the other direction. If two angles are adjacent, then they must be a linear pair. That is not true, right? If I have this angle here, and it's split, and I have angle 3 and angle 4, well, those two are adjacent, but that's not a linear pair. So if you were to go in the other direction, it's going to be false, okay? So this is a false biconditional, right? It's only true in one direction. Biconditional needs to be true in both directions. Okay. Another example could be talk about vertical angles. So if you have vertical angles, it exists if and only if those two angles are congruent. So are vertical angles congruent? Yes, that's true. But are two congruent angles going to always be vertical angles? No, you could have congruent angles that aren't vertical, right? So this is another example of a false biconditional, okay? So biconditionals only work if they work in both directions, okay? And that kind of goes with our examples where if you're proving something false, you can think of a counterexample. That's what we kind of did right here when talking about adjacent, okay? Think of if you can do a counterexample for it, and that's how you would know if it was false, okay? All right, second part of this video, we're talking about the law of syllogism, okay? And for that, we gotta think of our original statement, okay? So P implies Q, right? And then it just is kind of like a chain of events. So it's saying, okay, P implies Q, let's say Q implies R, and let's say R implies S, and let's say one more, just S implies T, okay? The law states here, okay, if you know that's your whole chain, then in summation, P implies T, right? P implies Q, well, we know Q implies R implies S, and S implies T, okay? So the law states, okay, we know P implies T. So let's just take a look at an example here. Let's say if you drive fast, then you'll get a ticket, right? And if you get a ticket, your parents will be upset. So upset parents. And we'll say, okay, if you have upset parents, then you'll lose PS4, right? So the law states that, okay, if you drive fast, that means you will lose your PS4. So it kind of just skips all those in-between steps and summarizes it, what we're looking at here. So if you drive fast, you lose your PS4. Okay? And so it kind of just skips all these steps, right? P implies Q, which implies R, and then in summation, P would just imply R here, okay? The only time this gets kind of tricky, and we'll do an example once I get back in class here, is like if it doesn't tell you it's in this nice, neat order, right? Like I put it in order for us here, but sometimes we'll see these all scrambled up, and it might say, give us this first, and then it'll give us this, and then it'll give us the last one, okay? So you have to think, okay, what is my first step and what is the last step, okay? So if you see this first where it talks about, okay, if you get a ticket, you'll have upset parents, well, you have to think if something caused the ticket, which you see in the first statement, driving fast caused that ticket, right? And then you'll see, okay, upset parents leads to losing a PS4. So that's the only time it gets tricky, is if it's not in a nice, neat order. But if it is in a neat order there, hopefully you can make that connection where something implies something else, and then that thing can imply something else, so on and so forth, until you get a general conclusion at the end, okay? So we also have another video of like a DirecTV commercial and using it. Hopefully you guys have seen that before, just to help wrap your mind about what we're thinking of when we're explaining the law of syllogism, okay? So hopefully that takes you through the end of the packet, and let me know if you got any questions.